The pleasure of introducing Andy Eschbacher. He is a key member of the data science team at CARTO. He's a retired physics teacher, retired. I'm not sure what the right word is there, but he is he's got a lot more that he can talk about than the time is going to permit. But he is going to talk. I mentioned the rise of the data scientist in my kind of opening monologue today. So he's going to talk about what's happening at the intersection of location and data science, and touch on some of the things that we've kind of seen and some of the things that we've added into our products as well to help support that. But let me hand it over to Andy.
Cool. Thanks, Ian. Is this working? Yeah, I think so. Cool. Yeah, hi, my name is Andy Eschbacher. Another factoid is Andrew Hill used to be my boss. He's our hard act to follow. So I was gifted this title for my talk, When Data Science Met LI, A Love Story. I apologize in advance for the groans, but hopefully they make it a little bit more interesting. So yeah, I want to talk about how some needs that we had on our data science team for CARTO and for data science stack were not quite met, and how we needed to create a solution to fit that. So I'm sorry for the meme. I'm really sorry. But like any good relationship, there's like this tension that you begin with. You have this desire. Maybe the tool that you're with doesn't quite meet the needs, and you're trying to like look for something better. So we had this need on the research team for stronger like data science and CARTO integrations. Python is our language of choice for doing data science, and so we needed some stronger integrations. A lot of our workflows where we'd be working in Jupyter notebooks, we'd output a file, we'd put it in Builder and CARTO, and then we'd analyze it, but we'd realize something was a little off, so we'd go back to the notebook. So there's this constant context switching, which was wasting a lot of our like mental kind of energy and time as well. And we also got some client requests for some tools that that allowed them to work with their data science a little bit better, and I think that they had some of the same pain points as well. And all of us use Jupyter notebooks or notebooks in general. There are a lot of, there's been an explosion of different types of notebooks in the last couple of years as well. We love notebooks. Reproducible workflows are really important to any scientist, data science especially. And we love Python. So there's this tension for something that we didn't quite have. And we were working with kind of these little code snippets here and there. So we needed something better. So some of the early flirtations that we had for creating something better, we would write some code. CARTO has some APIs for pulling off some of what we needed to do. One of the early things that we tried out, it was just over a year ago, I did a workshop on data science with maps. And some of the code that we wrote for that used CARTO's Maps API. The goal was to create notebooks, or to create maps in the notebooks, either static or interactive. And there's some of the code there. It was kind of complicated, it was awkward, but it worked. So here's another bad pun, I'm sorry. Swipe it right. Okay. Another frustration that we had is we needed to send the data to CARTO. So if we were working in a notebook, we'd usually just output it to a CSV and then drag it into Builder, like I said. But this was really cumbersome, a lot of context switching. Then we'd have to manually make the map in CARTO. It wasn't programmatic. We got out of our workflow too much, and it really wasn't working for us. So we wanted to find a better way. Another early flirtation we had was reading data from CARTO. Quite a while ago, I made a discovery that you can use CARTO's SQL API with Pandas read CSV, and you can pull the data into the Jupyter environment like that. That works so nicely, and that's part of one of the core parts of CartoFrames, which I'm going to talk about later in this talk. So that was a really good one. And so some of the other qualities that we're looking for a good partner. So these are some like early things that we learned. We really want an effortless CARTO data science integration. We want things to just kind of work so that we can focus on analyzing our data, solving our problems, visualizing the results, trying to convince somebody that we made a correct judgment based off of the data that we have there. We want data-driven maps. We want data scientists to not think about cartography. We want to have really good cartographic defaults so that the data scientists can work on communicating the data and their analysis and not worry about a lot of the intricacies of the data visualization. Built-in location data services, there's quite a range of these. Every API is a little bit different. And so when we built this, or when we want to build something, we want to make that part effortless as well. So if you need routing data or if you need to geocode, we want to bake that in so it's easy to use in the same tool set. Some other ones, I'm going to hit reproducible workflows a lot because being able to hand somebody a notebook, show your starting point, show your logic, show all of the steps along the way so somebody can find maybe an error in your analysis to make it better. Or if they need to do something similar, they can kind of fork it and then do their own thing with it. And like I said before, sensible and dynamic cartographic defaults. We want the maps to be really good. Something Carto really excels at is really good cartography, and we want to bake that into a data science product that we have as well. And then we also don't want people to worry about the intricacies of Carto's APIs. We want to just build a nice Python interface that a data scientist will act natively in, just like they do with other tools, and not have to worry about a lot of the particulars with Carto. So we chose Python. This is if you ever read XKCD comics, this is a really good one on Python. We love Python. It's one of the most popular languages for data science. It might be a little controversial. A lot of people like R, not me. It's extremely flexible. It has a gigantic and innovative community. So we want to build a tool off of that. And Jupyter Notebooks is another requirement that we have. We want whatever solution that we build for data scientists to really shine in Jupyter Notebooks. This is not a requirement, but what the whole tool set that we want to build, which is pretty much recreating Carto, but having it in a Jupyter Notebook environment, we want it to really shine. Jupyter is great because it has a really rich display environment, and so you can do static maps, interactive maps, plots, all sorts of stuff, all within the notebook. We want to take as much advantage of Jupyter Notebook's display environment as we can. And so that's the really strong requirement. Jupyter Notebooks are amazing if you've never used them. This is one of my favorite notebooks. There's a gravitational waves discovery made by this group called LIGO, and they published their work in a Jupyter Notebook. So I think it's a really great thing for citizen science and for peer review as well, because you can start with your data, show the analysis. You can even embed things like sound. Here they're showing frequency over time. This is when two black holes merge, and the frequency goes up, and you can see the intensity goes up as well, which is the lighter color. Cool. Okay, so I want to do a little bit of an overview of Python mapping tools and kind of look at what the wider environment is for creating maps in Python. One of the more popular ones that some of you may be familiar with is called GeoPandas. GeoPandas inherits a lot of the functionality from Python Pandas, which is a very popular data science tool for tabular data and a lot of other things. GeoPandas adds support for geospatial objects. It uses Shapely for geographic data. It has some basic plotting capabilities. You can see the map there. All you do is .plot. You can do choroplots by specifying the column names. You can have basic legends, but it's difficult to explore data on multiple scales, so it's not interactive. You get these static plots and things like that. It's a really great tool. It's really easy to use. And some other ones, you can create maps in Matplotlib, but if you've ever used Matplotlib, it is notoriously hard. You can do almost anything you want with it if you've got 2 or 3 weeks to do it. But if you just want to do one line of code to create a map, this is not the best tool. To create this map, which is from a really great blog post by Jake Vanderplas, it requires that much code, which is not reproducible generally. You could wrap it up as a function, but your data might change. And again, it's a static map, so if you want to explore the data, you're iterating over some data set, and you need to look at different regions and stuff. It's not the best way to explore data. Another tool is called Folium. It's pretty nice. You get leaflet.js maps in your notebook, which is really cool. Downside is that it's all local. It's not hosted like you would have with CARTO. It's very shareable. Has really great templating and HTML outputs. It's a great project. I find the API a little cumbersome to use. You can see that just a basic choropleth here requires quite a bit of code. And another one that kind of came up maybe in the last year is called GeoNotebook. It's pretty powerful. You have to set up your own map server. You can run it locally. You can have it hosted as well. It's not a very general tool, but it's really powerful for certain applications. And you can see here they're doing some raster analysis. But what we wanted was some of the combinations of all of those tools that I already talked about, but we also wanted to take advantage of CARTO. So anything that you can do in CARTO, we want to try to bring that into a notebook environment that feels natural to a data scientist. So what I'm walking through here is an interactive map I made. The essential 2 lines of code is that CC is a CARTO context. That's your connection to your CARTO account. You can create interactive maps. You can do it very similar to what you do in Builder by having multiple layers. The styling language for it, and you can do interactive or static maps. They're using the exact same template on CARTO. So it looks the same, even if you do the snapshot. You can see the styling language. I tried to make this as simple as possible by just saying, I want the color to equal this. You can have the color be a color, or you can color by a column, which would just create a choropleth. And you can size by a column. You can size by an integer. CartoFrames will automatically detect if you have a numeric data or if you have categorical data. You can overwrite anything in there by passing in a dictionary and kind of hard coding some stuff in there. You can do animated maps. You can do animated maps that are based off of a color as well. You can change the base map. So it's trying to recreate CARTO Builder, but programmatically that feels natural to a data scientist who doesn't necessarily know cartography at all. Yeah, so this is just the mapping component to it. There's a mapping component, but there's also a data component to it. So we're like moving in together now to kind of go along with the love story theme. We kind of identified our problems. We found someone who we like. This is the basic API for CartoFrames right now. You can read data sets into a data frame. It becomes 100% Pandas data frame, nothing fancy, just a Pandas data frame, which is really flexible. You can use it with tools like scikit-learn and anything else like that. Once you have a data frame that you've made changes on, if you have an output of a model, you can send that to CARTO, give it a name. You can override it if that table already exists or you want to change it. If you want 100% database access, we provide a query method, so you can do any arbitrary query. You can do spatial analysis in SQL, use PostGIS, anything that's on our servers you can use. With the maps that I showed on the previous page, you can add all the layers you would add in Builder. You can style each of them independently. You can do a layer that's just a query, so if you have some complicated query that you don't want to store as a table on your account, you can just pass in that query there and it'll visualize that. And we also have data observatory integrations. I tried to make data discovery as simple as possible because data observatory has such a large number of measures. And then each measure can have different denominators and or be normalized or be divided by area. So I tried to make that as the data discovery and data observatory as easy as possible. The output of that is a data frame. The next method down on that is once you get the metadata for whatever data augmentation that you want through Data Observatory, you can pass it to the data method, and it'll augment the data set that you associate with that metadata. And then you can also download any boundaries that we have in Data Observatory too. And then you can combine the last two to get like any snapshot of data. So like, let's say that you want census boundaries, and then you also want like these 10 measures for it. This is with CartoFrames and 3 or 4 lines of code, you can get any census measures you want that are normalized or whatever. Yeah. Cool. So some of the features of CartoFrames, you have full access to the PostGIS database. Location data services are baked in, so if you need to do routing or whatever other data services that we have, you can access a lot of that through the query option. We're going to be adding a lot of more Pythonic ways to interact with some of our location data services pretty soon, and I'll talk about that a little later. Carto colors everywhere, so Carto colors are the default. You can override those with your own schemes as well. Maps are static interactive, and you can have animated interactive maps as well. And then we're going to be adding animated GIFs for static maps. So if you have something that changes by year, you're going to be able to output an animated GIF for that. Advanced default cartographic styling. I think I talk about that a little bit later. But like I said before, we don't want data scientists to think about their cartography. We want it to just naturally pop out. But if they want to override anything, they have the ability to do that. And then the second to last point is a really important one, is we want to make it compatible with the larger ecosystem of tools that data scientists and GIS analysts will use. And so when you pull the data down from Carto into a data frame, you can actually add an additional column where the geometries are decoded into shapely objects and then pass that to GeoPandas. And then alternatively, you can send a GeoPandas data frame up to Carto, and the geometry will be in your Carto account, and it just works. Another thing that we want to do is take advantage of IPython notebooks. And so there's a lot of functionality that's already built really well into IPython, such as the HTML displays, and so we take advantage of that. Matplotlib, inline static images, and things like that. And I really think it shines in Jupyter notebooks. So a lot of people use CartoFrames just as an ETL process. So the read and write operation works really well for them because their data is already in Pandas data frames, and so they can just use 2 or 3 lines of code to get their data in and out of Carto. But the rich display environment really works well with CartoFrames. So another kind of larger level thing going on here is we realize that in Carto, we can't bring every analysis to Carto, nor would we want to. But the goal with CartoFrames is that you can bring Carto to your analysis. You can bring Carto to the workflow that you already have. We want it to work natively with whatever workflow that you have. And here is an example where I'm using Dask to do processing of OSM data that I think it's something around 1 billion entries. And you can use Dask to distribute the computing, which outputs a Pandas data frame, and then I write it to Carto and visualize it. So the number of analyses that any user will do, there's no way we can get that into Carto. So the philosophy with CartoFrames is that we give you Carto so that you can integrate that into your analyses. Reproducible workflow is just so important, just to be able to programmatically create maps off of whatever analysis that you're doing. To size things that make sense to you, to have legends that are proportional to the ranges of values that you have, to be able to give a zoom and a center to highlight something that you're interested in. The whole programmatic and reproducible approach to CartoFrames is so that you can tell your stories very conveniently in the Jupyter Notebook environment or your Python script. So the cartographic defaults, Voyager is the default base map, but you can use any of the other CartoFrames or any of the other Carto base maps. in there as well. And then we're going to be adding support for just any XYZ template in the near future. Base map labels respond to the geometry type. So if you have point geometries, you generally want the labels to be under the points. And so CartoFrames will detect that if you don't specify. If you have polygons, it'll put the labels on top so that the polygons don't obscure your labels. The marker outlines respond to the geometry type so that the actual data pops out more compared to the base map. Carto colors everywhere. For the interactive maps, it detects if you have a retina display, and it'll switch to a higher resolution base map. There's some other things in there too, but I won't go into them now. Programmatic, I keep hitting this. Sometimes you need to create a map that's like small multiples to compare different variables. The static maps in CartoFrames are matplotlib images. And anything you can do with matplotlib image, you can do in CartoFrames. And so here, I did small multiples comparing in this case, it's the same variable, but it's with 4 different schemes. So if you want, for our cartographer Mamatha, if she wants to compare how the different schemes react to different data or something like that, it'd be really easy to visualize that. But if you're doing a report, you can give a title for each of these plots and then show multiple variables at the same time. Data Observatory, I already talked about this a little bit, but I tried to build in as much flexibility for getting Data Observatory data. On the right, I'm just showing data discovery and then how you would get data for a table boundary. So you can specify a region being a table. So it just grabs I think it's a convex hull of your table. You can do it by region. You can just say everything in the United States. Or you can do it by bounding box by just specifying the lat-long pairs there. And the goal with this is that you can create something from nothing. So if you need to get raw census data plus the measures there, you can get all of that from Data Observatory. Okay, going back to the really bad puns. CartoFrames in the wild. So I wanted to show, so I recreated a map that our cartographer Mamatha did in CartoFrames just to show the range. But I wanted to show some examples of CartoFrames in the wild. There's a journalist named Jim Hodden who wanted to have real-time updates of power outages that were going on in Massachusetts because about a month ago we had pretty much one big storm every week on the East Coast in the United States. And so it was really important for his news organization to report this on an up-to-date level. And so he used CartoFrames to scrape the data from a state website, reprocess it, send it to Carto, but also send a backup copy to his Google Drive. And there's some other things in there as well. And then the result is they have this one Carto map that's on their web page, but their script is continuously updating it so that the people who are concerned about outages can just go to their website and see a map that's more or less real time of the power outages. Geographica, they're using CartoFrames very much for an ETL purpose. They're doing route optimizations for DPD, and they're also doing another route optimization project on waste collection for an engineering company. And for them, CartoFrames is this nice, easy piece to connect their analysis to Carto so that they can output it. Another thing that happened just in the last week is there's going to be a chapter on CartoFrames in this forthcoming book on geospatial analysis with Python that Pact Publishing is putting out. And I've been talking with the author over the last week, and I got a preview copy, and it looks pretty nice. Another project that I did, just kind of a prototype, is to create an analysis service. So one thing you're going to be hearing at this conference over and over again is Builder for Carto it's no longer going to be this monolithic piece of Carto. We're trying to break up Carto so that you can create your own things out of Carto, and CartoFrames is part of that movement. So what I wanted to do here is I needed to use Carto for some purposes, but there are other things like a certain type of analysis that Carto didn't have. but I still needed a service, like a server that was running an analysis. And I needed the outputs to like pull some of CARTO, but then use some other pieces. And so what I did, I wrote a basic Flask app that you send the table on CARTO, the columns that you're interested in, some other parameters, and it processes the data on the server, gives you the pair plot. It'll generate the interactive map using CartoFrames, and then it'll template that onto this web page that I have here. If you want to look at the code, there it is on my GitHub. But this is another example of bringing CARTO to your analysis so that you can complete whatever objective you have. That maybe CARTO has some pieces that are really crucial to, but the other pieces you need from other sources. All right, so what's next in the love story? Finally, legends. You saw some legends scattered throughout. Legends have been really hard for me to develop and make really well, but they're going to be coming in the very near future. I wanted to make them as convenient to a data scientist as possible, so I'm working on making the styling feel comfortable for a data science environment. And then I wanted the legends to be very much represent the data, so bins scaled by values, or you can overwrite that and have a more traditional legend. A nice side note is when I was working on the legends, I needed a programmatic way to access CARTO colors. There's a way to do that in Node, but not for Python. And so I did a pull request to Palatable, and CARTO colors are now in Palatable. So if you ever need to use CARTO colors in Python, you can pull them from this, this Python package. This is the thing I'm most excited about, this coming next with CartoFrames. We are creating an analysis, we are going to create an analysis framework. This is very much proof of concept, or not even proof of concept, this is kind of my dream of what it'll be so far. It's very much inspired by Spark, Dask, PostGIS, Postgres, and a lot of other tools. But the idea is that you create this directed acyclic graph. You have different nodes in there, different analyses, and it's lazily evaluated just like you would do something in Dask, so that once you build up your tree, you compute it, kind of distributes, it does some magic, and then gives you a result in an hour or 10 minutes or whatever, however complicated your analysis is. The computation runs in the cloud. Maybe we can figure out a way to do it locally as well, depending on the analysis. And then the data source nodes can be a table, it can be a query, other analysis trees, local data sets. I don't know, it's very much in discussion still, but I just can't wait till this comes out. I think it's gonna be amazing. We're gonna also replace the carto.js that we have in CartoFrames with a vector mapping library. I think vector maps work especially well for data scientists because the vector maps deliver the data as well. So if you want to build applications with turf.js or something like that, you can do local processing of the data through the map tiles. And if you send your data frame to a GeoJSON, you can read that into the vector map as well and display the data locally. There's a higher range of visualization options. You don't have to request the raster tiles from the server. We just think that having a vector integration with CartoFrames will be a much better experience for data scientists. Another thing, this one's a little bit further off, but being able to publish to Builder would be pretty powerful. So let's say that at the end of your analysis, you programmatically create a dashboard. Being able to push that dashboard to CARTO and having it be a Builder dashboard that you can share would be really powerful as well. So this is something that's on our roadmap. It's a little bit further off, but I just wanted to give you a taste of something that we could do. If you want to take it on a date, you can go to the CartoFrames repo and hit Launch Binder. Launch Binder, Binder is a service that gives you a dedicated Jupyter notebook. It'll live for 20, 30 minutes or something like that. You need your API key to use CartoFrames, but when it loads up, you'll get 5 Jupyter notebooks that we have in the CartoFrames repo. Just paste your username and your API key in there, and you'll be able to follow along and go through a lot of CartoFrames examples to learn. You can also check out CartoFrames in the Developer Center, like Javi mentioned this morning. We have a lot of documentation in there. There's a lot more coming. We see a lot of ways to improve it. And we're working on porting over a lot of the example Jupyter notebooks so that they're in the Dev Center as well. And yeah, now I'm ready for questions.